Hey, it's Aaron with a watch connectivity tutorial. We're going to talk about how you can get your iPhone and your Apple Watch to talk to one another for whatever uses you might have. Maybe it's a fitness app that you want to connect or something like that. So we're going to talk about that and then how you can kind of construct that into a connection service to not only be able to bring that connectivity between devices, but also do so in a pretty flexible way. So, without further ado, this is what we're going to get into in our video here. Talk a little bit about the framework and the requirements for the app, and then, of course, how you can add a watch app to your project. And then we're going to talk about how to use that watch connectivity framework to set up a watch connectivity session and what that is, and then how to pass messages and data back and forth, and then finally how to kind of tie it together into a more flexible system that we can use to pass information from one device to the other in the same kind of app. To talk a little bit about the framework, relies on this thing called a watch connectivity session to actually handle the inter-device communication between the phone and the watch. Or even watches, you can use it to connect with multiple devices from one phone. Um, and then on the receiving side, it uses a delegate and delegate functions to handle that incoming data and to select and fire the correct event handler. Um, and then it's also worth noting too that any messages sent between the watch and the phone are delivered in order, kind of like a TCP protocol works on the web. So the minimum requirements you'll need to be able to do the same kind of things that are going to be in this tutorial and its accompanying little example project are not too crazy. You just need to have Xcode and iOS versions 15 or better, and then watchOS version 8 or better. With the watchOS, though, if you plan on using any of the newer Swift UI functions in there or functionality, you will have to get 10 plus, so just something to note. And then also, physical devices are preferred for testing because there are some functionalities to the watch connectivity framework that you can't do in the simulators. You can make a new watch app, new companion app pretty easily. It's just like making a regular app or regular watch app, except you would choose instead of a standalone app or to use an existing app, obviously, to create a new companion app. But I wanted to get into how you would incorporate a watch app into an existing app because that's a little bit more tricky. And I mean, it's still pretty simple though. You just have to add it as a target to your existing app from the file menu at the top, and then you have to give it a technically new name. You could just append W to the end for watch if you wanted to, and that's fine. But it can't match. It can't be the exact same. And then after you add your app, you want to verify that the iOS app has the watch app listed in its build phases, and then also check the target membership of any kind of shared files that might exist in the project between the watch and the iPhone version. All right, so just real quick to go about how you would add your watch app to an existing app. I've just got a blank iOS project here with a silly little view model I've set up. But what you're going to do, I don't know if you can see this, but you go up to the top, go to File, New, and then Target. Then from there, you're going to pick WatchOS, excuse me. And inside WatchOS, you're going to pick App and Next. And then remember what I was saying is your name has to be different from the original, so I couldn't call it tutorial because my iOS project is called tutorial. So I'm just going to add a W to the end, um, and then set it for existing iOS app, and right there. And I believe you can use this other option if you wanted to go the other route to create the Watch app and the companion app all in one go. But um, just guessing it's going to be more likely that you're going to be attaching this to an app. I thought this would be more helpful to go over. So we're going to go ahead though and hit finish. And so you're going to get a prompt to activate the tutorial watch app scheme, and all that is just setting up a device on a watch to actually run. Like, how do you want to run this when you press play? So we can go ahead and activate that, and from there you can see we've got our original iPhone tutorial, now our watch tutorial. And so what we're going to do is, remember I said there was those couple things we need to check. So we're going to come in here, come down to build phases, and look into target dependencies for the iOS app. You just want to make sure that you see the watch app there. And then let's say you wanted to share this view model with your watch app instead of having to make a second copy to keep track of. You'll go to the file, you'll pull open the extra info panel on the right and hit this little plus sign. Now we can select the watch app here, press save, see it listed there, and now the watch app also has access to that same file. Coming back to talk about the code and the framework, the first thing that we've got to do is, in order to use this watch connectivity, is we have to set up a watch connectivity session. And what this will do is essentially be the facilitator for our device to device communication through Bluetooth and Wi-Fi, whichever it picks to work with. Um, but it'll be it's a singleton instance, so you'll only ever have one of these in your program that's running at a time. Um, and then before we actually inevitably activate this, we want to check if it's supported by the device we're running it on. But anyway, just to kind of dig through this code that's on this snippet that's on the right there, we're assuming this is going to be inside of our custom connection service object that we're going to make by the end of this tutorial. Um, and so what we've got to do is we've got to call the parent initializer and override the initialization function for NS object in order to use this watch connectivity session with our code. And so then we're going to call our start session inside of that initializer, check that our watch connectivity session is supported, set ourself to be the delegate. That's going to be, like I said, what handles our incoming data, incoming messages, and then actually activate the session so that we can essentially turn on the lights, say, hey, I'm ready for business. So after that is going to be our first delegate function that we set up, and all this does is it checks for that activation state to be returned. So this will be a reply from the other device, the whatever device is on the other end of the connection. And if it receives this, we'll print our activated session message and know that our session is ready to pass data, pass messages back and forth. One more thing that I want to know about setting up our session before we go on. This snippet of code that's here on the right is something that's going to be required for your connection system to work. Reason being, they're deprecated functions that aren't included with the watch, so you can't use them. If you try to define them in the watch, it'll throw an error. But if you try to leave them out for the iOS version, then it will also throw an error. So what you have to do is you have to set up these compiler directives or compiler conditions with this if and if that looks a lot like a preprocessor from C or C++. But doing this will allow it to compile correctly on both versions. Now we're going to get into essentially the meat and potatoes of what this is going to do is actually like passing stuff back and forth and how this works, how that's done. And so our first stop on this train is going to be the messages. And so what these are is these are a dictionary of strings associated with an any type with a asterisk there. That any doesn't literally mean any. You still have to use plist compatible data types, so numeric strings, et cetera, et cetera. But one of the perks is that it doesn't require any kind of encoding in order to pass this data around. You can just send it around as is. So it's pretty snappy, pretty quick, almost instant. The big caveat too is you got to check that your session is available or reachable, excuse me, before you send your message to make sure that it'll get to where it's going. Otherwise, your code will just kind of hang indefinitely, which is not good. So if we look at our snippet here on the right, the actual watch connectivity functions in the send is that send message, that session.send message, and session is reachable. So like I said, we're just checking there that our session's reachable, and then we're actually calling the function to send it. And this reply handler, we could handle this callback here if we wanted to. So instead of passing it forward like we're doing, we could, have a print statement or whatever, something to intercept that data. But in this instance, because this is going to go into our connection manager connection service, we're just going to pass that forward. And then kind of the same thing with the session. So this is another one of those delegate functions. And so this one is specifically set up for messages per that did receive message tag that's in there. Um, and we have it set to also send back a callback, which can, you could once again, you could handle this here instead of forwarding it with the reply handler reply, or you can forward it like we're doing here. Um, but this also shows too how you can check that an event exists and then check that there's a handler that goes with it. And lastly, you also, if you notice, even in the guards, there's a reply being sent back. You always, always, always want to send a reply anywhere that's anywhere inside these callback functions or inside these delegates. And the big reason is if you don't include that reply handler, your code will hang because your initial message will be waiting on a reply that might never come. So now that we know about messages, we can move on to message data. And so what this is this is just byte data that has to be encoded before you send it. It's technically of type data. And the perk to this, even though it takes that extra step and it's a little more involved to send things back and forth this way, is it's a lot more flexible with its data types. We're not just limited to those plist compatible data types. We can use anything, custom classes, whatever. And once again, you also want to check to make sure that your session is reachable before you send your data to avoid, like I said, hanging and having your program halt its operation while it waits for something to respond or just does weird things for that reason. But anyway, if we get into our code here on the right, again, this is kind of set up for our end goal here. So like the action parameter isn't necessarily necessary. And we'll get into more about why that's there and what that does. But as you can see, we're taking in a data piece, and then we're going to encode that data into the data type using our JSON encoder. Um, Now, if we weren't going with an additional level of abstraction or encapsulation here, we could just send this object data, but we're also, in this particular instance, we're also encoding that one more time in sort of like a data envelope to package that up before we ship it out. Um, but the end result is whatever gets passed to that send message data function has to be encoded before you send it. And then there's our reply handler again. It's just another callback that we can either choose to deal with where it's at or pass it forward like we're doing. And we'll get into why we've been passing these forward rather than handling them in place. Um, and then for our delegate function, that's our event handler, whatever is going to get called when this data gets received by a device. Uh, Pretty much the same kind of story here, just in the reverse. Um, and also the reason I say that that's the one that'll called, if you notice too, it's instead of did receive message, it's did receive message data. But anyway, like I was saying, you have to decode your data before you can use it. So in this instance, we have an extra decode step because we've wrapped it in this envelope. But otherwise, you could just just decode it and then call the data handler by whatever you used for your key in that collection. Before we go on, I did want to mention that those aren't the only ways that you can send information back and forth between devices. Those are just the two that we're going to explore here in our tutorial. But there are also these options that are listed. The transfer user info is essentially like a send like message, but it does it in the background. So it'll queue up events that whenever the device that is the intended recipient for them wakes up, it'll take those in and handle them. Transfer file, it's very similar to our message data. It's good for images, large data. Works essentially the same, but it does it like the transfer user info. It does this in the background rather than in the foreground. And then our update application context is just a way to keep things synced. Um, Similar to the send message, it uses key value pairs, um, but it only does a one-way communication. So you do not get a reply with that method. Um, and like I said, the first two you have to use with a physical device. You cannot simulate them. They won't work like that. And with the basics kind of put together and out of the way now, we can start to put together our connection service that we're gonna make that we can use to pass data between the watch and the phone and probably just about any project that we might need to. So we're going to talk about the routing dispatch, how we encode things, and how we set up our event dispatcher, and then also how the interaction logic works, where we register our event handlers, and then also where we can send messages and data from. So before we move on, though, got some flowcharts on the side there, kind of describe how these two functionalities work and what we're doing. So when we go to send, we're going to get our message data, determine whether it's a message or data. If it's a message, we're just going to send it because again, we don't need to do that encoding. Otherwise, we're going to encode our data and then send our data. And then same thing for the receiving, right? Our message comes in, our delegate function handles it, or rather routes it to where it needs to go, checks whether it's data or message, and if it's a message, just goes right to our dispatcher, right to the delegate function that handles it. Otherwise, if it's data, we've got to decode it first, and then we can pass it on to where it needs to go. Our first little sub step here is we're gonna come up with a data envelope and and an encoding function to kind of make our lives a little easier. Um, and so what this will do is this will just give us a way to store metadata about the data that we're passing around. Um, and then that action property that you'd seen earlier that I'd mentioned we would talk about, that's going to give us a way to add intent to our message, whatever, what is this intended to do, um, in a way that's easily actionable on, uh, while also keeping things, pretty generic so that we can make this more extensible, be able to support more different types of data, um, specifically by making that data envelope. But of course, because there's more steps, then it's going to add extra overhead to our processes, make things take longer. Every time we have to wrap and unwrap one of these messages is just another step in the process. So anyway, just to kind of go over this code on the right real quick. So we have our data envelope that we've come up with, right? And we've given it a type variable, and this will be just a string name that'll keep track of what describes our data type, what shape it is once it's been decoded. Our action is just an enum that we've made called action type. And again, this gives intent or meaning behind what our message is supposed to be doing, right? So instead of just sending an object, we can say, I want to get this object, or I want to update, read, the couple examples that I have here. Um, but it's a way to kind of route that without having to get a bunch of nested if else's. And then of course our encode function just takes in any kind of codable data, um, and then you encode that. And then since we're using our envelope, we're going to stuff it inside the envelope, give it an action, which defaults to none but can be passed in as something else. And then finally put our payload in, and then encode that all into our final data and return it. So to finish out our connection service here, or at least the routing dispatch portion, talk about our message and event dispatcher. And so what this is a function registry essentially. It gives us a way to define how we want to handle these, and then call on those handlers by name after we've given them a name, because they're just stored in a key value pair. And so what this does is for the send data function specifically, it lets us be a little more flexible, so we can come up with a kind of a generic method to handle that data, and also to set up the data handlers so that the connection service doesn't need to know anything about the data that it's receiving, other than it needs to be encoded. One thing you'll notice too, by the way, is our data handlers, the data and the register data function has an action type where the message does not, and that has to do with the fact that we can't encapsulate that message data, or that message information, excuse me, because it's just a key value collection. So there is no encapsulation. There's no way to add that action type in there, other than to just have it be a key value pair that's part of your collection that's getting passed. But anyway, getting into how these are working though, our handlers, as just a named collection of those key value pairs that encapsulate our message data. And then for our data handlers, um, we're using a generic function. And what this will let us do is, when we pass in um, a data type, it'll help us set up how we want to decode and encode that data. As you can see further down, when we get to like the decoded, um, and we'll see how that gets incorporated or implemented in just a little bit when we talk about how the delegate functions get set up to handle data that comes in. All right, so now that we have our connection service pretty much hooked up now, I guess the next question to answer is, well, how do we use it? What do we got to do to put all of this in action? So we're going to talk about our interaction logic here, starting with our registering our event handlers. And so the way this works is they can be registered from pretty much anywhere. The only stipulation there really is you just need access to that connection service object that we've been creating, have been creating. Um, Otherwise, the order that you register the events doesn't matter. They can always be changed and removed at runtime if you want to. I should note that if you define the register, or if you define a handler or register it more than once, only the later definition will remain in the collection. But yeah, so if we look at the code here on the right side, the first delegate function that we're defining up here, or event handler, I should say, that we're registering, um, is just for messages, message type data. Uh, so we've got our weak self reference there, and then we get our data that was passed in, then our data or our reply that comes back. And so what this will do, since we're going to be changing things in this code anyway, that affects the UI, it specifically is just that receive message, sent message. That's part of the example there, not necessarily part of what you have to do to use this. But we're going to wrap that in a dispatch queue, um, so that way we can make sure those changes take place. And then you'll see at the bottom of that, we're actually sending back forwarding that reply from our event handler. It's just going to get passed back to uh, where it's going to get called and used, whoever sent the original message. So then below that is our same thing but for data, and it's got some data type in there. That's just a custom data type that I put together for this example. I guess the name is specifically picked just because it's some data type. It doesn't matter what data type it is. It's just some data type, and this is really just to show how how you would use both the data to use the data type to define what your delegate function should respond on. And then also, if you look inside of its body there with the dispatch queue inside of there is a switch on that action that we were talking about. And this kind of, lets you set things up um, as sort of a command pattern, I guess you could say. So I'm using a switch case here, but I'm sure you could use a key value collection where your value is some kind of a function or something else that you want to run. But in any case, this is kind of showing how you can catch that, both catch the delegate function based on the data type, and then how to react to that data type based on the intent variable that gets passed in with it. Then to finish off our interaction logic and really our connection service that we've been putting together to this point, is our send messages, send data functions. And like registering the handlers, these can be used pretty much anywhere you want to use them, anywhere you need to use them. So your view models, really just anywhere that has access to this connection service singleton that we've put together and assembled here. Um, and so the way it works though is that closure that comes from the reply gets handled wherever it gets called. So say you need to reassign a player or something, or send data about a player, and you're expecting data to come back that needs to be reassigned or whatever it might be. Anyway, the you can do that where you call this send function, so that way you don't have to pass the view model or whatever is containing your data around. You can pass just the data that really needs to be pushed from one place to another. And so this helps really to decouple the data and transport layers from one another. So that way our connection service doesn't need to know um, doesn't need to know much of anything about where it's being used. It doesn't care if the code that it's being used at describes a physics engine, if it describes a player object or some other object in a game. As soon as it's been encoded into our data, um, it loses, all of its context or whatever until you rebuild it on the other side. But yeah, so if we look through our code here real quick on the right, um, send message is really just more of the same for our message type data or message type interactions that we've been talking about, where they're just the key value pair collections that we're passing back and forth that kind of contains our instructions. Um, and then our send data itself, kind of you can see how we can use the use a data type to package up and unpackage that message, that data that gets passed to and from one device to the other. Um, you can see where we decode it for into our envelope that we've created, and then we finally decode it into its final time or final data type before passing along some kind of a reply. Um, Now that we've gone over essentially how this connection service gets put together in our slideshow, we can kind of dig into this example that I've put together I think will really kind of tie everything together. So before we do, if you run a watch app that connects with an iPhone app, you have to have a paired watch and iPhone to do that with. So to set that up, all you're going to do is open your simulator. Since I have my phone and watch up, I just got to click one to open that. But you'll go to File and then New Simulator, and then inside of there, you'll select this paired Apple Watch button, and then pick whatever your other values are, and pick your watch, and hit Create, and it'll generate a new paired phone and watch for you to use. Moving on, we're going to get into this example that uses that code that we just talked about in that slideshow. So to start with, here's our connection service, which is it's the exact thing from the slideshow, right? Here's our action type enum, our connection service class, the data envelope that we've created, our singleton instances, encode function, the handlers, registration functions, um, start a session, check if it's activated, and then our delegate functions to handle replies and our send functions, right? So on top of that, we've also got a view model, and both of these files are shared. You can tell that by the target membership here. It's got both the original, the iPhone app, as well as the watch app listed in there. Right, so here in our view model is just some real basic data. What message has been sent, what's been received, what data has been sent, what data has been received. Our connection service reference here, which really we can just assign with this dot shared because it'll always point to the same instance. But we're passing it in just to kind of show that you should really be using this as an injection. Um, It'll just help keep things decoupled. So if you ever wanted to replace it with something else, you could. Um, but anyway, so therein in our initialization, we can see our event handlers, our message handler, and our message data handler being instantiated here or declared and defined. And these I believe are the same exact ones from the slides, really. But then our send message, send data, and you can see that both of these handle their closure inside of the function itself. I should mention too that I forgot to mention this in the slides. This reply handler, we set equal, or we give it a default value of nil. And what this does is it lets us either use the send message or send data functions to expect a reply, or we can also set them to be kind of fire and forget. So if we don't specify a reply handler, these will act with a fire and forget behavior. Whereas if we do include that handler, it'll wait until it receives that reply. Now, digging into the code a little bit more, we've got our iOS implementation and our watch implementation here. They're pretty much, for all intents and purposes, one and the same. The phone just happens to do it in a single screen, whereas the watch needs a few, just because it's so much smaller to be able to display that data in a legible way. Um, but anyway, as for what this does, how it works, well, aside from the obvious, it sends information back and forth. What we're going to do is we can start with the watch here. Now, if we put in a message, just put in a bunch of letters. Oh, no autocorrect. All right, that's okay. So if we hit send though, we should see this collection of characters show up right here as is in the received message on the phone, and then it'll append its name to the end of that and send it back. And so if we send it, you can see we get our collection of characters there. And then on the reply message, we've got iOS. Now it's stored in that it sent that set of characters from WatchOS, and then we've received it back with iOS instead now on the end. And we can also do this for our message data. So if we push some more buttons here and we get a new word to send, we're going to go ahead and send that. And the same thing here, we've got our collection of letters iOS, and the sent on the phone, and then collection of letters iOS and the received on the watch. Now, real quick, the reason that these don't have watchOS at the end of them is because that first initial send does not have the platform appended to it. Otherwise, each time it came in and got sent back, it would have an ever increasingly longer, essentially list of which could be helpful if you needed to do some debugging or something, being able to see that. But I thought this was cleaner to see and to look at. But anyway, so now if we come back, we go to our wait to receive, right? So this is the watch now waiting for data. And so we can just type something in on the phone here real quick. And if we send it as a message, we get our hello watch OS, and then we can even see here, right? We got our received from the watch, sent from the phone. And now if we do, just so you know, there's no goofy business, just do another word. We'll just do jump, sure, why not? Send that as data. And so we've got our data sent out from the iOS, received back from the watch, our data received from the watch or from the iOS, and then sent back from the watch. And yeah, so then like I was saying, those values are getting set here in this delegate function, right? So if we send data from the phone to the watch, it's going to get set in here on the watch, or excuse me, it'll get sent here from the phone and then be sent here in this delegate function on the watch, since it's the one that's receiving the data. And if the reverse was the case, then the opposite functions would handle it. A couple more things to share about WatchConnectivity and how this works. Right, so if we have this open, we're able to send messages back and forth. And before I get to what I was going to say there, When we go to launch our watch app, um, you'll notice if I restart this watch app that it's gonna or rather close out on the phone. And that'll happen every time you've got to restart your watch app, and then you have to start your phone app after the fact. Um, but you can, however, and then let me just do a thing just to show that it's a different instance, right? So if I send some data, change the UI. Now if I restart my phone app, um, it'll restart the phone app without having to restart the watch app here. But anyway, so what I really wanted to show though was, let me restart this watch app, right? So we're not going to open the phone app this time though. Now there is a stipulation that in order for this all to work, you do have to have opened that app on the phone at least once, and paired up your watch. But right, so without that open, I can come in here and set up a message, press send, and we get our response from a phone. And if I come back here to data, I can do the same thing here, and we can see the hits keep on rolling. We get that back from the data. Um, Now, however, so we're going to exit out of the app here, and if we open it in the phone this time, we're going to start fresh with a new execution, right? So we've got a clean, we haven't sent anything, haven't passed anything, so there's no stale information, right? If we do the same thing from the phone here, and we pass our hello as a message, comes in, right? But if we do it as an object and pass it as data, you notice that we do not have a response come back from the watch. And so what this is the phone is much more readily accessible from a background state than what the watch is. So you might be wondering now, is this the end? Is this what we're all we can do with this? And well, no, not really. There's actually a lot of places that we could take this connection service that we put together and apply it someplace else. We could use it with the widgets and the complications for the watch faces and the phone faces. Um, let's use a combination of WidgetKit and Swift UI, and that's how you get those little informative blocks on your phone, for example, that lets you see, weather information or bank information at a glance. And same thing for the watches. It's the way that you get that at a glance snapshot displayed onto the main screen. Um, Also being able to use it with, say, core location to get location services like GPS navigation, things like that. You use that for, just what it is, location, and being able to know where you are in the world, or, making an app that generates some kind of route, or maybe uses that as a game mechanic or something like a Pokemon Go type game. And then also being able to use sensor data, right? The watch itself has quite a few more sensors than what the phone does, including heart rate, things like that. So you could use this connection system that we've built to pass that kind of data back and forth as well. If you wanted to make any kind of an app that works with that. But that really is the end for this one. And until next time.